Hey everyone, and welcome back to the channel. If you're an Angular developer, you know the feeling. You walk into that interview, you're ready, you've studied, and then, boom, a question hits you that makes your brain do a triple somersault. Those trick questions that leave you second-guessing everything. Well, are you tired of feeling stumped by complex Angular interview questions? Do those trick questions leave you second-guessing your expertise? This video, my friends, is your ultimate guide to confidently tackling even the most challenging Angular scenarios. We're going to decode common pitfalls and demystify complex concepts, giving you the edge you need to ace your next technical interview. Or to put it another way, imagine walking into your next Angular interview feeling completely prepared for anything they throw at you. This video is designed to make that a reality. We're breaking down the trickiest Angular questions, providing crystal clear explanations and practical strategies, so you can confidently showcase your skills and land that dream developer role. Sound good? Let's dive in. First things first, let's understand the mindset of the interviewer. Why do they ask these seemingly impossible questions? It's not about rote memorization. They're not just checking if you've memorized the docs. Interviewers are testing your problem-solving and critical thinking. They want to see how you approach a problem, how you think under pressure, and how deep your understanding truly goes. They're setting common traps. These questions are often subtly phrased to expose gaps in understanding. It's like a puzzle. The surface looks simple, but there's a hidden complexity. And critically, the why matters. It's not just about the correct answer. It's about understanding the underlying concepts being probed. If you can explain why something works a certain way, you're golden. Interviewer, so you've used ngIf before. What's the difference between star ngIf condition and style.display condition.block.none? At first glance, you might think, well, they both hide show elements. But the tricky part is the implication. Star ngIf removes the element from the DOM entirely. Style.display only hides it, but it's still in the DOM. This tests your understanding of DOM manipulation, performance, and structural directives versus attribute directives. The why here is about performance and resource management. If you need to remove something completely to save resources, ngIf is your friend. If you just need to toggle visibility and maintain state, style.display might be acceptable. All right, let's get into the nitty-gritty. These are the concepts that often trip people up. The legendary change detection. Everyone knows Angular detects changes, but do you truly understand how? The tricky question usually revolves around OnPush versus default strategies, and when to use each for performance. The trick: if you're using OnPush and you mutate an object or array passed as an @input, Angular won't re-render your component. It only checks for new references to the input objects. Default change detection. Angular checks every component in the tree on every change detection cycle. Simple, but can be slow for large apps. OnPush change detection. Angular only checks the component if an @input reference changes, and an observable in the template emits, and an event originates from the component or its children, and you explicitly trigger it. Change detector ref detect changes or mark for check. The why for OnPush is massive performance gains. When to use it? Almost always, unless you have a very simple component with no performance concerns. Just remember to treat your inputs as immutable. RxJS, powerful, elegant, and a source of countless interview questions. Specifically, switchMap versus mergeMap. These both flatten observables, take an observable of observables and give you an observable of values. The tricky part is their behavior when a new source observable arrives. SwitchMap. When the source observable emits a new value, SwitchMap cancels any ongoing inner observable subscriptions and subscribes to the new one. Think type-ahead search. If the user types AP, then app, you don't care about the AP results anymore, only app. mergeMap. When the source observable emits, mergeMap subscribes to the inner observable, but it doesn't cancel previous ones. All inner observables run concurrently. Think send multiple emails. You want all of them to go through. Oh, the why for SwitchMap is to prevent stale data and race conditions, especially with user input. The why for mergeMap is to handle multiple independent concurrent operations. Dependency injection, DI, is fundamental, but what about the nuances? The tricky part often involves provided in root versus providing a service in a specific module or component, and the implications for tree shaking. Provided in root. The service is a singleton, available throughout the application. Crucially, it's tree shakeable. If no part of your application actually injects global service, it won't be included in your final bundle. This is the recommended modern approach for most services. Provided in ng module providers. The service is available only to components within that module's injector scope. If that module is lazy loaded, the service is also loaded lazily. It's not tree shakeable in the same way. If the module is loaded, the service is loaded. Provided in component.providers. A new instance of the service is created for each instance of that component. This is useful for component-specific state or resources. The why here is about application bundle size, lazy loading, and ensuring the correct scope for your service instances. Always think provided in root first for global singletons, and then consider module or component providers for specific use cases. Components are the building blocks of Angular, but getting them to talk nicely can be surprisingly complex. We all know @input and @output for parent-child communication. But where do things get tricky? Often the trick is knowing when to use @viewChild, and more importantly, when not to. @input and output, the standard preferred way for direct parent-child communication. Pass data down, emit events up. Clean, predictable. @viewChild allows a parent component to get a reference to a child component instance or a DOM element. When to use. For specific, imperative actions. For example, focus this input, reset this form. Or when the child needs to expose a method for the parent to call, and you don't want to make it an @output. The pitfall: child component will only be available after the view has been initialized, ng after view init. If you try to access it in ng on init, it will be undefined. Also, it breaks the component encapsulation a bit, making the parent tightly coupled to the child's internal implementation. The why for favoring @input or @output is maintainability and reusability. @viewChild is powerful, but should be used sparingly for specific needs. What if components aren't directly related, or you need global state services to the rescue? For example, the trick is knowing when to use services for global state, and critically, how to avoid service sprawl, where every piece of state ends up in a different service without clear organization. It's a non-negotiable for real-world deployment, perfect for holding current state and emitting it to new subscribers immediately. Use an observable as observable for public access to prevent external components from directly modifying the state. When to use. For application-wide state. For example, logged-in user, shopping cart, global settings, data shared between sibling or unrelated components, or data fetched from an API that multiple components need to observe. Avoiding sprawl. Organize your services logically. Don't put everything in one giant service. Group related state. For example, auth service, product service. For very complex global state, consider dedicated state management libraries like NGRX or Akita, but start simple. The why is about creating single sources of truth, reducing prop drilling, and enabling efficient communication across your application. Whoa, another communication conundrum. When do you use @output with event emitter versus just using an RxJS subject or behavior subject directly? The core difference lies in their intended scope and reusability. Event emitter, primarily designed for output properties. It's for direct parent-child communication, signaling that something inside the child has happened. It's tied to the component's lifecycle. RxJS subject, behavior subject, more general-purpose observable streams. When to use? For communication between sibling components, unrelated components, or across services. They offer more flexibility. Examples: multicasting, operators, error handling, and can live beyond the component's lifecycle if injected as a service. The why is about selecting the right tool for the scope of communication. For simple component outputs, event emitter is fine. For anything more complex or application-wide, go with RxJS subjects. Wait, performance is paramount. These questions often test your understanding of Angular's internals and how to make your apps scream. Zone.js, the invisible force behind Angular's change detection. Many developers use Angular for years without truly understanding it. Zone.js patches asynchronous browser APIs like setTimeout, addEventListener, XHR to notify Angular when something might have changed, triggering change detection. Role: Zone.js intercepts asynchronous tasks. When these tasks complete, Zone.js tells Angular, hey, something happened. You might need to check for changes. This is why you rarely need to manually call detect changes. Optimization strategies. Running outside Angular Zone for very frequent or long-running tasks that don't directly affect Angular data. For example, a WebSocket connection continuously receiving data you only process occasionally, you can run them ngzone.run outside Angular. This prevents unnecessary change detection cycles. Change detection strategy OnPush. As we discussed, OnPush helps limit the scope of change detection, reducing the work Zone.js triggers. The why for understanding Zone.js is to grasp the magic of Angular's automatic change detection, and more importantly, how to optimize it when performance bottlenecks arise. Big applications mean big bundles. How do you keep your initial load times snappy? Lazy loading is a critical performance optimization strategy. Lazy loading. Instead of loading all modules when the application starts, you load them only when the user navigates to a route that requires them. This significantly reduces the initial bundle size and startup time. Module bundling. When you build your Angular application, Webpack or a similar tool bundles your code into several files, chunks. Lazy loading creates separate bundles for each lazy loaded module. The why is simple. Faster initial page loads lead to a better user experience and higher engagement. Interviewers want to know you can build scalable, performant applications. Another crucial performance concept, AOT compilation. When you run ng-build-prod, Angular performs AOT compilation by default. What it is: AOT compiles your Angular templates and components into highly optimized JavaScript code during the build process, before the browser even sees it. Benefits: faster rendering. The browser doesn't need to compile templates at runtime, so it renders much faster. Smaller bundles. The AOT compiler can perform better tree shaking, eliminating unused Angular code and reducing the final bundle size. Earlier error detection. Template errors are caught during build time, not at runtime. Better security. No client-side template compilation reduces the risk of injection attacks. Common issues. Sometimes, specific patterns that work in JIT, just-in-time compilation, for example, calling functions in templates that aren't public, might fail in AOT. The why for AOT is about creating production-ready, highly performant, and secure Angular applications. It's a non-negotiable for real-world deployment. It's not just about what you know, but how you apply it and how you interact with a team. Describe your debugging process when you encounter an unexpected bug. Well, interviewers want to hear a structured approach, not just "I Google it." Example answer: my debugging process typically starts with trying to reproduce the issue reliably. Once I can reproduce it, I'll start isolating the problem. 1. Browser DevTools. I lean heavily on Chrome DevTools or similar. I'll check the console for errors, network requests for failed APIs, and the Elements tab to inspect the DOM. 2. Breakpoints. I use breakpoints in my code to step through the execution, inspect variables, and understand the flow. 3. Logging. Strategic console.log statements or more advanced logging libraries help trace values at different points. 4. Version control. If it's a regression, I'll use git blame or git bisect to find when the issue was introduced. 5. Hypothesize and test. I form hypotheses about the root cause and then test them by making small, isolated changes. 6. Team collaboration. If I'm stuck, I'm not afraid to ask a teammate for a fresh pair of eyes. 2 heads are often better than 1. You propose a solution, but a senior developer on your team disagrees. How do you handle it? This tests your professionalism, communication, and ability to work in a team. Example answer. First, I'd listen carefully to their reasoning to fully understand their concerns or alternative perspective. There might be context I'm missing. Then I'd present my reasoning again, clearly articulating the pros and cons of my approach, backing it up with data, performance metrics, or best practices if available. If we still disagree, I'd propose exploring both solutions, perhaps a quick proof of concept for each, or bringing in a third, neutral party for an objective opinion. Ultimately, the goal is to find the best solution for the project, not just to win an argument. I'm always open to being convinced by a better idea. How do you stay up to date with the rapidly evolving Angular ecosystem? This shows your commitment to continuous learning. I have a few ways I stay current. 1. Official Angular blog and release notes. I follow the official Angular blog and always read the release notes for new versions. 2. Community and conferences. I follow key Angular influencers on Twitter, subscribe to newsletters, and watch talks from conferences like ngConf. 3. Hands-on practice. I make an effort to try out new features or changes in personal projects. Theory is one thing, but practical application solidifies understanding. 4. Documentation. The Angular documentation is incredibly thorough. I often refer back to it. 5. Podcasts and YouTube, like Frontend Insight Channel. There are many great Angular-focused podcasts and YouTube channels that provide insights and discussions. So, arm yourself with this knowledge, practice explaining these concepts out loud, and walk into your next interview with confidence. You've got this. If you found this video helpful, please give it a thumbs up, subscribe for more Angular content, and let me know in the comments below, what's the trickiest Angular interview question you've ever faced? I'd love to hear your stories.